Hello students, here we'll discuss Cardan's method for solving a cubic equation. Now, the general form of a cubic equation is given by x cubed plus 3x squared plus cx plus d equal to 0. Okay, but which cubic equation is of Cardan's form? You see, if you have an equation, cubic equation, which is of this form, then it is called a Cardan's equation or Cardan's form. So these kinds of cubic equations can be solved using Cardan's method. Now what happens if in the cubic equation you have this kinds of terms present? That means if you have, suppose you have to solve x cubed minus 2x square plus 5x plus 1 equal to 0. Okay, you want to solve this equation. Okay, so here you can see this is not of Cardan's form because here we have a term like x square. Okay, so in those cases our task is to remove this term x square and reduce this equation to Cardan's form, and then we can use Cardan's method to solve this kinds of equation. Okay, so let us go into the method which is called Cardan's method for solving an equation of this form. Okay, so let us take an example. So let us try to solve this equation. Okay, so you can say this is of Cardan's form. So what is the method here? Our first step, so say this is our equation 1. This is the given equation. So our first step is to assume x to be sum of two dummy variables, say u plus v. Okay, so if I, so cubing both sides will get, okay, so here you can see if you take cube on both sides, so you will get u cube plus v cube plus 3uv times u plus v. Okay, now what is u plus v? You have assumed this to be x, right? So you can see this is equal to u cube plus v cube plus 3uv x. Okay, so what do you get over here? You're getting x cube minus of 3uvx minus of u cube plus v cube, that is equal to 0. So this is your equation 1 and this is your equation 2. Okay, so now if you compare these two equations, equation 1 and 2, you will see, so what is your equation 1? That is a given equation, x cube minus of 9x plus 28 equal to 0. This is your first equation, and you have derived x cube minus of 3uvx minus of u cube plus v cube, that is equal to 0. So if you compare these two equations, you will see minus of 3uv, that is equal to minus of 9. Okay, if you compare then you will see the coefficient of x in both the equations. It is minus of 3uv equal to minus of 9. So from here you will get uv is equal to 3. Okay, next you are getting, if you compare these two equations, you will get the constant terms to be, so it is minus of u cube plus v cube, that is equal to 28. So that implies u cube plus v cube, that is equal to minus of 28. Okay, so this is what we are getting. So now, so we'll try to form a quadratic equation whose roots are given by u cube plus v cube, u cube and v cube, right? Now from the relation of roots and coefficients, it is already known to you. So suppose you have an equation ax square plus bx plus c. Okay, so that is the quadratic equation you have. Okay, so suppose alpha and beta are the roots of this equation. So what are the relation between roots and coefficients? So you'll see the sum of the roots is equal to minus of b by a. that means the coefficient of x divided by the coefficient, that means the leading coefficient. Okay, and what is the product of these two roots, alpha beta? It is given by c by a. So you can see, if the equation is known, you can write the relation of roots and coefficients, right? Similarly, suppose this equation is not known to you, okay, but you have the roots, the sum of two roots and the product of two roots of some equation. So if these two datas are available, so from there, suppose this is not known to you, right? So this equation is not known. Instead, you have the information that sum of alpha and beta is given by minus of b by a, and product of alpha beta is given by c by a, right? So I have to form the equation whose roots are alpha and beta, right? So you will see, so suppose it is t square. So t square, if you consider t square plus alpha plus beta into t plus alpha beta, you will see. So if you consider this equation, you will see, so what is alpha plus beta? So it is t square minus of, so it becomes b by a times t plus c by a equal to 0. So here you can see, if you simplify this, you will get at square plus bt plus c equal to 0. That means you are getting the same equation you have started with, isn't it? So you can see, so if product of two roots and sum of two roots are known, from there we can form the quadratic equation. Okay, so here you can see, so here we have sum of u cube and v cube. So sum of two roots are present over here. So we want to form an equation, a quadratic equation whose roots are u cube and v cube, right? So here sum of these two roots are present. So we can obtain the product of the roots also, right, from this equation. So what is it? It is 27, right? So from these two informations, so we can form a quadratic equation, okay, whose roots are u cube and v cube. Okay, so let us write the equation. So t square minus of sum of the two roots times t plus u cube into v cube, that is equal to 0, right? So now you see, what is our u cube plus v cube? That is equal to minus of 28. So you are getting plus 28t plus 27, that is equal to 0, right? So this is, so we are getting a quadratic equation which we can solve very easily. So it is t square plus 28t plus 27 equal to 0. So we can factorize it, right? So it is t square plus 27t plus t plus 27, that is equal to 0. Okay, so you are getting t plus 27 into t plus 1 equal to 0. So what are the roots you are getting over here? It is minus of 27 and another one is minus of 1. Now you can see, this can be written as, so this is the equation whose roots are u cube and v cube, right? So let it be u cube, that is equal to minus of 27, which can be written as minus 3 whole cube. Okay, so what is u? I can take the first possible value of u as minus of 3, and here let it be v cube, which is equal to minus 1 whole cube. Okay, so our v is equal to minus of 1. Okay, so what is our x then? So we have started with x equal to u plus v. So u plus v we can take as 3 minus of 1, that is equal to minus of 4, right? So we got one possible root of the given cubic equation, right? So which is equal to x minus of 4. Now you see, from factor theorem we already know, so if x minus a is a factor, so from factor theorem, so if x minus a is a factor of some equation fx, okay, then we can, then x minus a perfectly divides fx, and fx can be written as x minus a times qx, right? Okay, so if x minus, that means if a is a root of an equation, that x minus a becomes a factor of the polynomial fx. Okay, and I can write this as fx equal to x minus a into qx, right? So if I divide fx by x minus a, we can very easily get qx, which is going to be, so if fx is a polynomial of degree 3, if you divide this polynomial by x minus a, you will get qx, which will be a polynomial of degree 2, right? So here you see the given equation is x cubed minus of 9x plus 28 equal to 0, and you have obtained one root of this equation to be x equal to minus of 4. Okay, so x equal to minus of 4, this is our equation 1, right? Is a root of the given equation 1, right? So from factor theorem we can say x plus 4 is a factor of 1. Okay, so x cube minus 9x plus 28 can be written as x plus 4 times qx. Okay, so qx would be a polynomial of degree 2. Okay, that would be a polynomial of degree 2, that means a quadratic polynomial which we can very easily solve, right? So let us try to divide this by x plus 4. Now you are dividing a cubic polynomial by a linear polynomial with leading coefficient 1, right? So here, so we can use our non-synthetic division to divide this equation, right? So if I want to divide this by synthetic division, so here we'll write minus of 4. Now what are the coefficients? So what is the coefficient of x cube? It is 1. After that, there should be a term involving x square, which is missing over here. So its coefficient must be 0, right? Next it is minus of 9, then it is 28. So 1 comes over here. So 1 into minus of 4 is minus of 4. Okay, so minus of 4, if you multiply these two things, we'll get 16. So it is 7. So if I add minus 9 and 16, you will get 7. Then it is minus of 28. Okay, so the remainder must be 0 because x plus 4 is a factor which perfectly divides this equation, right? So what is our qx? You can see, so our qx is x square minus of 4x plus 7. Okay, so we have to solve this equation, so which is a quadratic equation. So if I want to solve this quadratic equation, so this equal to 0, so you can apply Sridhar Acharya. Okay, so what is x? So it is minus 4 plus minus of 4 whole square minus of 4ac, that means 1 into 7 divided by 2a. Okay, so what do you get over here? 4 plus minus root over of 16 minus of 28 divided by 2. So from here you will get 2 plus minus root 3i. Okay, so what are the roots we have obtained then? So our solution is, so x equal to minus of 4, that is the first one. Next we'll take 2 plus root 3i, and then we'll take 2 minus of root 3i. Okay, so these are the values of x or roots of the equation, given equation, cubic equation. Okay, so this is our solution.